friends, today we are going to explain the Quarky IR sensor, how it works and how we can use it for line following robot. So mainly today I'm going to explain about how to calibrate these two IR sensors. So you can go through this Quarky document where it says there are two pair of infrared sensors in both sides and how it works, like the transmitter transmit infrared signal, it reflects the object and returns back, and the receiver detects and reports how much the value. And fortunately, the Quarky IR sensor reports analog value and also digital value you can get out of it. So that's a good part. I'll come to that next. So today's topic is how to calibrate the two IR sensors for this lines. So what is the need of calibrations? So to follow the line, you should know what is the number the IR sensor reports, or what is the signal comes from the IR sensor when it hits the white surface in your track, when it hits the black surface, and when it hits the green surface. So you know in the track to green is the penalty. So if you go to the green, there's a penalty. So all these three color is important for us for the codever. So in that aspect, it's very important to know that how to calibrate it well. So well calibration, what it means, well calibration. So it's just a calibration, right? So when it is well calibrated and when it is not well calibrated, that's coming next. So the other point is when the IR sensor, the IR transmitter falls, the light falls, the IR light falls on the black object, it absorbs almost everything and then nothing reflects back to the IR receiver. That means you should get a very low value like 38, 40, 80, depends on the surroundings. And that's what we are, that's the principle we are using for a line following robot. That's why you see always the line following robot track is black and white. That's the highest contrast. It will be less ambiguous. Similar like the binary number system we use for the digital system or electronics, because 0 and 1, 0 volt and 5 volt, that's the highest possible distance. Okay, leave that part. So yeah, this is how we calibrate, we try to calibrate. So the calibration, during the calibration process, you have to move the Quarky like this, left and right, and the light will reflect on the green surface, then white surface, then the black surface, and you have to find out it should exactly sense when it is crossing the black surface. For a better calibration example, you will see immediately the light will turn the other color, or means it will immediately sense that I have crossed the black color, and a bad sensor will be very late to figure it out. So what is the implication for that? When you figure it out very late, in the meantime, when you have already crossed the black color, already you have crossed, and then you realize it is late. In the meantime, by then you have already entered the green surface, means you have already out of track. Maybe it will try to recover in that state and try to find back and go, but it will be too much of left and right, and you will be having lots of penalties. So that's the problem for a bad calibration. So calibration is very important, and the procedure mentioned in the website is okay. Let me go to that procedure. So I will not cover the Python one. Let it be as much kids friendly as possible for the lowest age group as well. So this is the one where it is saying that okay, you manually change the threshold value. What is the threshold value? So the threshold value is the number what so the IR sensor will be reporting you value anything from 0 to 4096, and then in middle any value. So we are expecting in the black color it should return us some 96, 98 based on the surroundings and other factors. And for the white, the maximum like 4096 or 3000 or a big value. So that's what the expectation. And green should be something close to the white and far from the black, because it is also reflecting, not like a black that absorbs everything, but not as good as white. So this three kind of value we should get, but every time that it reflects, it corresponds to a value between 0 to 8096. So what is that value which signifies that it has crossed the black or it is on the black? So that's the threshold value. So once it crossed the threshold, suppose you figure it out somehow that 3200 is when it is on the black. So when the IR sensor is seeing the black color, it is 3200. If you know it, then you keep your threshold just 3199 or 3150 to be for it to be very sensitive. But don't keep it very close, otherwise it can give you false alarms. But very less chance, because as I told, black and white is a high contrast. So it will be a sudden change when you will move to the black zone. So okay, so the main point here is you have to keep exploring the number of written in this threshold, the 3000 value. You have to keep changing and see how it is impacting. So this is the procedure. You calibrate the value high, black region will not be detected in this case, reduce the calibration value. So you have to reduce the calibration value and try again. Then you see, okay, it's somewhat working. Let's reduce it more. So it's an experimental value. Now, today I am going to explain you about some other way I have found it more useful, and it's up to you if you want to use it that way or this way. Let me explain the my way of calibration. So this is what is as per the PictoBlox documentation, how to calibrate. So I have already connected the PictoBlox. Let me show you. So first you go to the board and select PictoBlox. Then you go to connect, and then it is already connected. So if I disconnect, you will see the port COM4 is connected. Now I connect, and you see, okay, yeah, because I've connected to the data cable, there is no color indicator here. Oh, but yeah, it's connected. Yeah, it's connected. So the blue color came now. So it's connected now. Now, if I click on this, so I am starting with a threshold of 3000, and I click on the flag. I should not click here. I should click on the flag. So both will be activated at the same time. And you see both are red. And now if I move left or right, you don't see any impact on that, because 3000 is way out of the threshold what you are expecting. Just for fun, I'll just take it out in the open air so that the IR sensor, the IR transmitted value will not reflect on the ground, and it will go to infinite, and it should read something very low. So once it receives something very low, the color became green. So there is something going on. At least we know that green, and the color is changing, but it's extreme. It's in the air. When it's in the air, it's green, and then here, nowhere it's changing to green to red. So that's the situation right now. Now let's see. If I go by the procedure mentioned in the website, it is coming like this. Do it 2000 and then stop and start again. See how it is working. Oh, now see. The left side I changed. And then just by one change, I can get a good improvement. But are you satisfied with this experiment? You might be trying to see, is it really 2000 is the bound, or can I be more precise, like 2100, and see is it performing better? Or if I make it 2000, 1900, the other end of the boundary, and see is it working better. So that's the constant try, and you have to pinpoint further in the digit, like, okay, if I see 1900 is the one, whether not 1940 or 1950 and then 44. So finally we will end up with a magic number that will work here. So this is the procedure. Keep calibrating and improving. Now let me come to my way of doing it. So what is the trigger point for me? So if you go to the search and search for IR, and you see there are multiple things. One of them is get value of IRL, which indicates, so this one, what it indicates? It indicates that you give a number and this final is IR left sensor is active. It's just a yes or no. Means is this going to return like this light? It's going to return either true or false. It's black or not black. That's it. But you know this Quarky IR sensor has more potential than this, and that is what lying inside this block, because IR sensor are of two different kind. So if I Google it, IR sensor, and you see the various kind of IR sensors. I want to drag your attention to two different kind of IR sensor. This has 3 pin, this has 4 pin. So if I go to the 3 pin IR sensor, you will see this one. So it's mentioned as out, ground and VCC. So this out is most probably a digital out, true or false. But if you go to the other one, which has 4 pin, and you go to the next, where is that marking? Okay, let me go to the air sensor. So if you go to any of this, I believe you'll get it. PCC, ground, out, and RL. No, not this. Yeah, this was what I was talking about. So this is the best one. You get that 4 pin IR sensor, which has digital pin. How it works? This is the physical potentiometer. You have to put your screw in and then calibrate. You have to rotate. This hard calibration is doing by physically rotating a screw. But in PictoBlox, we don't have something like that. You're doing it by typing. So that's more convenient, right? And how it is enabled, that will come next. But what I'm telling is, this is what impacting the digital sensor. So by tuning this, you're actually impacting the digital pin 0 or 1, black or white. That's what you're calibrating. But for the analog pin, it is an infinite possibility. Not infinite, it is the range the analog ADC converter supports between 0 to 4096 for the chip we are using here, which is the ESP32. So knowing that it has not only 0 or 1, it has multiple possibilities starting from 0 to 4096. You can be more fine-tuned and you can better play with the analog pin than the digital pin. That's what I want to point out. And from that point of view, this is the value that's going to help you. Instead of playing with is IR sensor active, yes or no, let's play with get value of IRL. So let's see how it works. So for that, because the ESP32 lying behind the Quarky has not exposed the serial pin in the Quarky board, at least for the PictoBlox website, PictoBlox software. So what I have done is I need to constantly get the reading. That's my main point. So what I have done, I am dumping it into a data logger. So data logger is an extension. By default, it may not be here. It will not be here. You click on the extension and go to the search window and type data, and you get the data logger. So I already have activated the data logger, and then you get these points, these blocks. So first of all, you have to give a name of the block. So I gave test IR sensor green, white, black, GWB, anything. Okay, and then this will create a file on this name with this name. Then how it's going to write? It's going to be a CSV file, comma separated value. So how it looks like? So it will look like something like this, comma separated value, and you can choose what should be the values. Like say you say the first column or first value before the comma will be something, then comma, then the second value, third value. So these are called data number, data 1, data 2, data 3, like that. So you can mention that which variable in the PictoBlox you're going to write in data 1, 2, 3, like that. So given that this is the data you're mentioning, the column or what is the index in this comma separated value if one in one row. That's what you're mentioning here. So I'm saying that first is the timestamp. So that's what you see in my example. The first one is the timestamp up to this until the first comma. This is the timestamp, date's timestamp. I'm not using it, but I'm just noting it. This is the second one, data 2 and data 3. Others I'm not using. So coming here, data 1, data 2. So data 2 is the left sensor. So I want to calibrate the left sensor first. And And believe me, this is going to be very precise and you don't have to go by your luck. That's what I want to tell. So for this, let me stop it. And where this file gets generated, for that you have to go to document, PictoBlox, data logger. Here it's generated. So let me delete. Oh, it's not generated yet. That's the old file I was using. Okay, I deleted everything. So let me click on the flag. But before that, I have a plan here. So you have to go by plan. Otherwise, you cannot go unsystematic. That the value will not have any meaning then. So I am calibrating the left sensor. So I have to be very careful about the left part of the sensor right now. This is the left part for me. So this left sensor, while in putting down, I believe that is the sensor, left sensor. And that's what I want to calibrate. So how we will calibrate? I have decided to swipe like this. I will keep the left, I'll keep the left sensor on the green for 2 or 3 seconds. Then I'll slowly move to the white and keep it there for some time. Then I'll move to black and I'll go black back to the white and then green. That's my plan. So let's start. Before clicking the button, position yourself. Position yourself. Let's be in the safe position. And I want to be here. I want to better to hide the background. I have this plywood. Better to make it black color so that you don't get any noise. Okay, this is a risk I'm taking, but okay. Let's start. So now I started collecting data. You see the file got generated and it is collecting data. So almost some 2-3 seconds passed. I'm moving it for the variations. This green color printout, it may not be even everywhere. We expect it's even, but due to the fold in the paper and many other reasons, the green may not be everywhere same. So it's not a single value you're going to get. You're getting multiple value for the green. So I'm just slowly moving to the white. There will be sudden change in the number, and that is what defines the border between green and white. So now I am in the white for some time, and then I will move to the black. Hope I am in the black now. I'll move very slowly so that I can get enough point for black. Then I go to the white again, and then going to the green back. I think I'm done. Let me close it. Let me open the Excel. See, there are lots of value. Let me open the Excel. And yeah, I need to register it. For now, yeah, this is the value. I have 2 value only. Others are only blank. There is nothing after the comma. Leave it. So this is I'm not interested. This is what I'm interested. What I'm going to do? See the value. For the green, it is reporting 1500 range, and then 1100, and then it's very hard to read, right? So what we will do is we are going to plot it. Select the column B, go to insert in the Excel, go to line, draw the line. See, there are the peaks, there is a peak. So you see the first value is 1500. So I started with green color, then I went to the white, and then this is the peak for the black. So I think, yeah, I said black will give you the lowest value. Looks like it's the inverse. So yeah, we'll see how the thing works, but the working principle is same. It is all lights are absorbed and there is no light, and that is pointed as a higher value here. So yeah, so this is the value corresponds to black. Let's see. So if I want to draw something on this to tell you, I want to insert a shape, line shape. What I want to tell you, if you cut it from this point, then you will be at the center of the black. And once you go towards the white, there is a upside down bucket, or we say Gaussian. Forget about it. So there is a this shape. This shape is telling that black color is not evenly giving us the value. So there is a peak. So better to be little down in the peak, 3 decibel point or something we say, but forget about it, the technicalities. Just see, this is the safe value, I would say. But if you take the value something from here, then it will be merging with the white color. That's the thing we have to avoid. So to what it implies in the real world, or what is the intuition behind this number or this graph. So if I cut it from here, and then if I choose the value from here, so let me click on any of the number and hover on it, and I get a point 1369. Oh, no, sorry, value is 2235. 2235. I will zoom it little bigger and then click somewhere here. Okay, let me move this line. It's disturbing me. So somewhere here, what is the value? 2202, and this is 2235. So I would take this value. This is a good cut, 2202. So I'm saying this is my cut point. So 2202, what it implies? So if I type 2202 here in my 2202 in my calibration, this is going to give me the best possible uh, sensitivity for my left IR sensor. That's what it means. So that is how I ended up calibrating the IR sensor for left. And see, I just in one value, just in one test, I found out a value. Let's see how well it is working for the left sensor. Let me detach the right sensor to not to be distracted, and just try with this sensor. Okay, so let's play this. This is red. Once I am in the black, it is green, and the change, you see the change is very subtle. I'm just moving little bit and it's changing. And the other side also. This is red, this is green. Oh, what happened? Oh, I should look for this guy. So this is in green. This is in green. Now, oh, sorry, this is red, means white color, and then it got triggered, means IR sensor active, means it got green color, and then very quickly it turned to red. And this side is not detecting. What happened? So let's go down further and find out some other point. So now this is my next cut point, 1882. So let's take that, 1882. Stop it, start it over. Now let's see. Now see, red, green, red. So that was very much sensitive. We should not go to that zone. Now it can sense the two side of the peak. This is the peak. It has one side and the other side. What is this one side? This is the white side. This is the white in the left side, and this is the white in the right side, and this is the black side. This is the black strip. So if I cut this way, looks like we are able to cut the whole thickness of the black, or something somewhere in the border, and it is able to sense just precisely the black. Let's stop it. Start it one more time. Green, red, green, red, green, red. So we got a value. Similarly, we will do for the right side sensor. How to do that? We'll just go to this part and then change it to R, where else, nowhere else. And then here I want to say underscore, or no, let me delete it and recreate. Or let me close it first. Close it first, don't save. And let me mark it as a historical data, and make this right. And then, oh no, started already. Let me delete this. I'm not ready yet. Okay, now it is equipped to calibrate the R right side. So now see this right side. I have to move like this and see. So what I will do? Let me check one more time. Is it really left or right? So if I put upside down, So what is the right? When I put it upside down or downside up? When it is called left or right? So if I hold it like this, upside down, and then we say left is this and right is this, that could be one reason we might have got this wrong. So let's see that. I will make it L again, and I will assume this is my L sensor, L left, because if I put upside down, this is my left sensor, which is finally going to the other side. And let's try to calibrate with that. So what can be done? There is another way of doing this. That's a good way, I believe. So this one, I will make it 3000 for both of them, and then start. Both are red. Now it's green, and then I will not make it green. What I will do is, for the red sensor, for the right sensor, I make it blue. Okay, and then start, and this one I will make it somewhere green is already used. I'll make it yellow. Okay, start. So this is my initial position. So this is saying that I am the right side and I'm the left side. Oh, then I'm okay. So this is the left and this is the right, and that's what it is. Leave it. Then I will put it back to green. So no worry, we are in the right track. And let's calibrate the right sensor, left, right, and then delete this. It's stop this and delete this. It's not there now. Put it here and start. Green, white, black, white, green. Stop. Let's go. Similarly, open and then plot it. See, there is a very nice peak. This is the black cut. So I want to cut it from here. Now I am not putting any. I can see 1600 is a good peak, and there is a clear contrast difference. And I don't know, this is white, this area is white, or this area is white. I think this is the green. This could be white, or this could be white, I don't know. But I am interested on black, and there is a big separation. So I will take 1600. So I will go here, take 1600 for this, and for this one, let me try one more time, because it looks like very nice. I will do one more time. Close it, and then delete this, and then try one more time. Left sensor, and then close it. See if I get a perfect Gaussian curve or not. Yeah, nice. So I got a value right around 2122. I'll give 2122 here. 2122. Done. So I will detach this now, and let's start. Have it together. Green, red for the left, and green, red for the right. What if exceeds further and this side, red for the left sensor? It is starting from here. On the black is green, again red. So this is the crucial point. Both sides, the left sensor is sensing red, and in the center is green, and same for this thing. So they are perfectly calibrated, I believe. Hope this was helpful for you. Please let me know in comment. But one more question here now. So this is calibrated in my home at this particular lighting condition. Let me go and switch off one of my tube light. Now the light is a bit less. Let's see if it still performs the same way. Yeah, good. Because the light coming from the tube light is not infrared. Any infrared source can interfere, but because this is a visible light, looks like it has not interfered. But in case if you're in a place where there's an interference with infrared, suppose you have calibrated it at your home and you have hard coded this value 2122 and 1600, and then once you're on the track to offsite the place where the in competition is happening, and you see it is giving a different value, is not turning properly, what you will do? I believe you should come up with a code that can do auto calibration on the spot. So what you are doing actually is can be formulated. You can make a formula out of it. What will be the formula? It's a simple formula. You just get the values, and then find out where is the peak, what is the maximum and minimum of the whole data. So you can do it this one like this. Go to the last, and then here, and then say min of the whole number starting from top to the down, and then give a bracket, enter. So this is the minimum of the whole number. So you see here in the graph, somewhere around this is the minima. If you hover the mouse, come on, zoom it and put it here, 1182, and see it should be approximately around that 1182, 1179, almost just 3. So finally, if you see somewhere here, this is the value 1179. That's the minimum of the whole. So by programmatically, you can, this is the place. So this is the place where the value was minimum. So programmatically, you can find out the place where is the minimum or the base, but we are interested on the maximum. So let's go and change it to max. Max 2320. 2320. So that's what we are interested. So you see the distance between minima and maxima is 2320 and 2320 and in enter 1179. So there is a big gap. Just be little down from 2320 and ensure it not touches the 1179. Something around 2200 or 2100. So programmatically, you can give a threshold and find out how to calculate on the spot without hard coding the value. And that way you can calculate. How to do that? Do you want a ready-made code? I believe not. You want to try yourself. But if you are stuck anywhere, let me know. Call me in WhatsApp and I will help you out to find out what is the auto calibration code for calibrating Quarky. So that's what the takeaway. After you know the logic, how we are really approaching to this way of calibration, you should be able to find out a automated way of calibrating instead of even doing this Excel work. So we have 3 level of work now. Once you found in the website mention about trial and error, the same trial and error we are doing, but in more systematic way by using the Excel and using the analog value coming out of the sensor. And the third level is doing it on the spot every time, so that there will be no mistake doing the calibration. So that's what is the closing statement. I want to tell that this is not enough to be within the line. There are many other factors that you have to keep in mind to keep it in the track and not go out of track. And one of them is how is vibrating, shaking left and right, fast, and that is one of the calibration is one of the thing that will reduce the shaking like this too much. It can shake little bit like this, like this, if it is well calibrated. But even if you want to smoothen it, you want to smooth it out. For that, you have to go to the advanced IR sensor. So you can say QRKY, Quarky, Quarky advanced line following, follow, follow, and then you get some other blocks, which is advanced line follower, turn robot, IR. This is known, but there's an advanced version. Where is that? This is the, oh, yeah, this is the advanced one. Okay. Initialize, turn robot, set parameter f t1, t2. Okay, this I have been left, right, middle. PID. Yeah, so this is the one. Proportional integral derivative, and these are the constant for proportional integral and derivative. It is a big topic we're not going to cover, but that why I want to tell is if you enable the advanced line following, then it will not even do this ones. So the worst thing is doing this and going in the green. The better thing what we learned today is doing this, but still it will shake like this. And if you want to remove the shake or you want to smoothen it up like this, you will get a benefit at the edge. This is the edge where it will be really making sense and you'll be getting a real fast turn. So you have to, there's a trade-off between how fast you can go without getting out of track. When you go fast, because you have to complete all the 4 or 6 tasks, so you have to go fast and do things. But if you go too fast, then once you're out of track and this light detects late, you will be out of the track. So you have to be a trade-off. There have to be trade-off that you have to go fast enough and not slow enough so that you don't go out of the track, and still you can finish all the 6 tasks in 2 or 3 minutes. So that's the challenge. So how to cope up with that? For that you might need the PID sensor, and but first step is this calibration. So that's what we learned today, and that's automated way of thing. For that you can ping me in WhatsApp, or any question further on this, or anything you want to point out in the video that might have gone wrong. Please let me know. I am open for any feedback. Thank you so much. Bye bye.